Okay. Okay. We were just getting ready to convert 1/3 into its decimal equivalents because I want to show you what a repeating decimal looks like. Of course, we're going to divide. One goes inside, one goes outside. I'm going to add my decimal, bring it up, and add my 0. 3 goes into 1, 0 times. 3 goes into 10, 3 times. 3 times 3 is 9. 10 minus 9 is 1. Remember, we don't want any remainders. Add a 0, bring it down. 3 goes into 10, 3 times. 3 times 3 is 9. 10 minus 9 is 1. I don't want a remainder. I'm going to add a 0. Bring it down. 3 goes into 10, 3 times. Are y'all starting to see a pattern here? No matter what I do, I'm always going to get 3 times 3, which is 9. I'm always going to be subtracting 10 from 9. I'm always going to get 1. Bring down that 0, becomes a 10, and that cycle starts to repeat itself. This decimal is called a repeating decimal, where this same 3 just starts to repeat itself over and over and over again. So the way we write that, when we see that the same digit is going to keep repeating itself, all you have to do is write the digit that repeats itself one time and put a bar on top, just like that. That bar lets me know that this digit repeats itself. Kind of like if I were to write a decimal that looked like this, 1, 6, 3, and the bar was over the 3, that tells me that only the 3 keeps on going, 3, 3, 3, 3, 3, 3, 3, 3, 3. But if I saw a decimal that looked like this, that tells me that this decimal is 1, 6, 3, 6, 3, 6, 3, 6, 3, 6, 3, 6, 3. And yes, that does happen. These are called repeating decimals. Okay. Thank you all so very much for paying attention to Method 3. And we've got one more thing to talk about. Improper fractions and mixed numbers. Okay, we're going to talk about both of those things together. We're going to start with mixed numbers because they're the easiest. A mixed number, remember, is a whole number followed by a fraction. It's a mixed number. You are going to eventually have to change this mixed number into its decimal equivalents. Now, remember, there's a whole number there. The whole number doesn't change. Whole number is still going to be the same, the whole number. The only difference is that the whole numbers sit to the left of the decimal. The fraction is the only thing you're going to have to change. Now, we've learned 3 different methods on how to take a fraction and change it to its decimal equivalents. So, which one of those 3 methods work for you? Doesn't matter to me. But we've learned 3 different ways. We're going to practice 3 different ways. This is obviously not a tenth, a hundred, or a thousandths. So I could always change it to 1. I can change my fifth to a 10. How do I go from 5 to 10? Times 2. And I also want to take my numerator, times 2. 4 tenths. I know that 4 tenths as a decimal looks like 4 tenths. So that means that 1 2/5 is the same thing as 1 and 4 tenths. So as you can see, there's no difference in changing the mixed number. There's no difference at all. The whole number goes to the left. You're going to use one of your methods that you've already learned to change the fraction to its decimal, and the decimal goes to the right. Okay, we're going to do one more of those. Next example is 17 whole number, so it goes to the right. I don't have to do anything to 17. It's the 2/8 that I'm going to have to change. Now, I can go through my three methods. 8. Can I change 8? Can I change 8 to a 10? No. Can I change 8 to 100? No. Can I change 8 to 1,000? Well, I probably could, but that's a lot of division. So, how about I'm going to take method 3 and convert it. I'm going to divide. I'm going to put my numerator inside, my denominator outside, add my decimal, bring it to the top, add a 0. Now I can divide. 8 goes into 2, no times, but 8 goes into 20 twice. 2 times 8 is 16. 20 minus 16 is 4. I don't want to have a remainder. Add a 0 so I can bring it down and keep on dividing. 8 goes into 4 5 times. 5 times 8 is 40. 40 minus 40 is 0. I'm done dividing. Whole numbers go to the left. My 2500ths goes to the right of the decimal. 17 and 2/8 is equivalent to 17 and 2500ths. So as you can see, there's clearly no difference in the way that we handle mixed numbers. Now we're going to take a look at improper fractions. An improper fraction would be a fraction like this. (15/4). Okay? Clearly, I don't want to divide all of that. I could, but we're going to take this improper fraction and we're going to practice a skill that we already learned. How to change the improper fraction to a mixed number. So we are going to divide. And then divide the top by the bottom, just like last time. Okay? 15 goes inside, 4 goes inside, outside. Okay? It doesn't matter which number's bigger or smaller. As long as the numerator, the top, always goes inside no matter what it is. The denominator, the bottom, always goes outside no matter what it is. And we're going to do the same thing. Put a decimal, bring it to the top. We're also going to go ahead and add a 0 because we know we're going to need it. 4 actually does go into 15. 3 times. 3 times 4 is 12. 15 minus 12 is 3. And then bring down my 0. 4 goes into 30 7 times. 7 times 4, 28. 30 minus 28 is 2. I don't want to have a remainder. 0. Bring it down. That becomes a 20. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. I am done. 15/4 is the same thing as 3 and 75/100. So we just took an improper fraction and changed it to its decimal equivalents. I know this is a lot of information to take in, so I want you all to watch all 4 of the videos, parts 1, 2, 3, and 4, every single night until we work our way up to everything that you've seen. This is our ultimate goal, being able to convert all types of numbers to their decimal equivalents. Thanks for watching. I'll see you in class. Bye.